All right. Let's talk about macronutrients for a little while. There's 3 categories of macronutrients. There's the non-mineral. Non-mineral meaning what? Somebody answer.
Inorganic?
No.
Man-made?
No?
Not from love.
Yes. From the environment, usually from a gas within the environment. So we're talking about carbon, hydrogen, oxygen. Ourselves, we're made of an awful lot of carbon. Where does that carbon come from? It comes from the air. We actually absorb it, turn it into cell structure. So these are non-minerals. We'll talk about that in a second. We'll get to it. There's the primary and there's the secondary. Let's look at this table here. Everybody understands that 99.9% of plants have phases, right? Just like humans, you have adolescent phase, and then you start to mature, become sexually active, you completely change to a totally different person, and then you start to desiccate and die, okay? That's life cycles. So, vegetation phase, that's the growth phase, and then you have the flowering or the fruiting. This is when plants start to bloom. There are different requirements for macronutrients during different phases of plant growth. I just need you to understand that with this table. These aren't all of them, but here's several macronutrients. Nitrogen, phosphorus, potassium, calcium, sulfur should be in there as well. And what was that? Okay. I'm listening for camera noises here. So nitrogen, obviously, pretty consistent throughout the growth of the plant, right? Very little amount in the beginning, and then all of a sudden it needs a whole bunch and pretty consistent. But right near the end, most plants don't need, they start to taper off and don't really need as much as they did throughout all of their growth, okay? Nitrogen, one of the most important macronutrients needed throughout the entire phase of the plant. Phosphorus. Without me getting to the slide that talks about the functions of these minerals, without me even getting there yet, what can you tell me based upon this table about phosphorus? Yes. Yes. Just by looking at this table, you could tell that phosphorus is usually that uses that mineral, the plant uses that mineral to produce flowers and to go through that specific phase of its life. So the demand for that is much higher during the flowering phase. Almost to the point where you can go without any throughout the entire growth phase. Potassium, what is it telling us? This table. Let's think about the blooming stage. Let's cut it in half. What happens in the first part of the blooming phase? Flowers appear. Then what comes after the flowers? Fruit. So what is it telling me on the orange? Very, very important for the fruiting phase of plant growth. Calcium, pretty consistent throughout the blooming phase, and as well as magnesium. Sulfur is going to kind of stretch throughout most of it. Do you see this here? This little wave, whoop, 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 and then it cuts back. Do you see it?
No.
Why is that there?
I thought it had to do with that hydrocarbon word.
Yes, it's not. Oh no, it's not part of this. This is actually the same color, and it's really, really light. It's because right about to the point where the plant goes from seedling and starts getting some. It's not so much the roots as the stems. So plant becomes a little bit more hardy. Plant comes up, and it's the first thing it does. It turns super woody at the bottom, and then as he starts to grow, it gets super woody to give it structure and strength to hold the weight of the fruit. So that's super important right here. Real quick, whoop, it needs a little bit of that. So you got to make sure that not only are you putting it here, you need to put it here as well. But you got to remember that almost every crop has a a different requirement for these macro and micronutrients. Turns out I'm on this side today. It's just the way I'm rolling today. Oops, don't die. Good, okay. All right. Everybody understand this concept? Any questions about this? Awesome. Don't be lying to me now. Non-mineral elements. We just talked about those. Put these down in your notes. Because I don't want you to forget them when we start talking about the homework. Question number 1. Anybody want to look at, why don't you, Matt, read off question number 1 for me.
The micro and macronutrients, also this plant functions and deficiencies.
Yes, so be sure you look at your homework real closely when we're going through this. You're going to need this on that nutrition question in the beginning. Most people start with NPK. I want you to start with CHO. Why is carbon, hydrogen, and oxygen important? It is, what is a plant, why is a plant so special? Give me a couple reasons why plants on this earth are super amazing special things.
They don't need the humans.
Huh?
That's what I learned in my botany class. They don't need the humans. The humans need the plants. But they can take
This
things
is correct.
from the atmosphere and create food for themselves.
That's the answer. They are able to make food for themselves from the environment. All they need is a few things. Not always, but they need water, sunlight, carbon, oxygen, and hydrogen to produce food. Their food is carbohydrates, sugar. They produce sugar inside their cells. Where do they get the minerals to create these sugars? They get it from the air. Carbon, hydrogen, and oxygen exist in the environment. They don't exist independently from each other. This one does. But they don't exist independently of each other. They actually bond together within the environment. So you get things like carbon dioxide, right? Carbon, di meaning two, oxide. Oxygens. 2 oxygens in a carbon is carbon dioxide. Hydrogen, H2O. Now you can visualize these compounds. This is why these are called these things, and we're going to go a little bit deeper here in a bit, okay? H2O. You take carbon dioxide and H2O, you mix it together with ATP, you don't need to know that, within the plant structures to create a sugar. That's why we get this word carbohydrates. Hydrates meaning what? What does it mean to hydrate? Water. Water bonded with carbon. That's all it is. Boom. Enough said, right? So plants take up these gases. This isn't part of the homework or part of this class, but you know how? It's part of your reading. I gave you guys in the book. How's it? How do plants take up gases? You're on it. Close. Stomatas. Stomatas. It's not stigmata. Something different. We're going to do a brown leaf today. That camera. This is not very important as far as this class goes, but you really need to understand this, I think. You got a leaf, right? If you take a leaf, take a microscope, and you look up underneath, what do you see? If I flip this leaf over, so we got the bottom side up, look through a microscope, you're going to see little holes on every single leaf. They're all over the thing. And these holes actually look like this. So, if I'm looking straight on to the stomata, right? Each one of these dots right here, right? What happens is, during the nighttime, plants, they don't breathe. They actually take the energy that they produce in the sunlight and start doing cell division and do their growth at night. Most of them, not C3 plants. We won't get into that. Cactuses and stuff don't do that. But for most part, plants, they kind of go to sleep at night, and they kind of, just like you and me, we kind of do our metabolic activities at night and process all of our energies, get ready for the next day. Sun comes up. What happens? This is a little hole that's being plugged up by two flaps. Okay? The plant, and this is actually one cell, has a nucleus. This is another cell, has a nucleus. The cell that's around the outside is only one cell. So it's basically two cells inside one cell. Then the plant wakes up, sun starts coming up. Actually, maybe an hour before the sun comes up, it senses that the sun will be up soon, and it removes the water from these two cells. It pumps it out. What happens? It opens up. Just like that. Gas goes in and out. Carbon, oxygen. How does carbon and oxygen go into the plant? Carbon dioxide. It comes in together as one. It doesn't just come in carbon and then some oxygen. Carbon dioxide enters here, goes in, turns into carbohydrates, turns into sugars. What comes out?
Water.
Yes. What else? Oxygen. Right? Also a little bit of nitrogen gas. But for the most part, it's oxygen that comes out. That's how plants breathe. That's how they take in these non-mineral elements. Any questions on that? Okay. Now, picture this. You have a spray, some sort of insecticide, something like that. And you spray it on this leaf during the day while it's doing this process. What happens? For a split second, and then the plant will react. And we know what it'll do? Because you're spraying a spray on it, it's high moisture content, it'll think, you know what, this is a really heavy rain, and I don't want to take in more water vapor than I want. So in the middle of the day, you're out there spraying it down. What happens here? Closes up. Totally closed. While it's supposed to be doing the process of exhaling and breathing, you come along and you spray in the middle of the afternoon. It can't breathe anymore. And it has this harsh chemical on the outside. And it can't really do its activities that it needs to do to react to those chemicals that you're putting on the outside. Even organic, naturally farmed stuff, you put it on a plant, it's going to react this way. So you got to understand that plants behave just like humans. They need their time to breathe. They need their time. There's a timing factor on everything. Plants go through 100 of these different little weird quirks a day, these little processes. You need to understand all of them to understand your plant. You walk along and you do some of that soap stuff, the safety soap, which is probably the best organic insecticide you could put out. If you don't put it out at the right time, you could seriously damage your plant. Okay? I got off a rant there. Didn't mean to talk about that, but it's super important. Any questions? Let's go on to the next macronutrient. We're talking about the primary nutrients now. We talked about this on the first day of class on the pretest. what do the 3 numbers on the side of a fertilizer bag mean? Somebody answer, please. Hey, look at that, it's right there. All right? Those 3 numbers mean these things. What are those? Can you remember these pictures? If I said NPK, would this give you a visual of what's going on here? Growth, right? Cell division, leaf development, all that stuff. Roots and flower. And this is going in, this is the phase of going into flower, and then, because this is a lily, so this would be the fruiting phase of a lily. Okay? And please, I need you to learn the abbreviations for the minerals. If you get any recommendations back and all that stuff, it's just going to have a letter. You need to know what it means. Nitrogen, phosphorus, potassium. It's a K. Why? Latin, but we won't get into that. So, you need to figure out a way to remember that K is potassium. How could you do that? Can we think of one now? Man, I had no sleep, otherwise I'd probably be able to come up with one. All right, so just remember that K is going to be potassium. My inventiveness is way off today. I'm glad we're not talking about marketing. We'll get to that. Secondary nutrients. These are still macronutrients. They're still needed in almost the same quantities as the other 3 I just mentioned. Calcium, magnesium, sulfur. Remember when I was talking about limestone? What effect does limestone have on soil? Correct. It raises the pH. We'll talk about why in a second. You actually understand that. But knowing that we're going to probably lime most soils that have organic matter in it because they usually have a lower pH, which are going to be most soils you're going to farm. You're going to be liming it, which means you're going to be putting limestone in or calcium carbonate to change the pH of your soil. Most times when you do that, you meet this requirement for here and here. Because within calcium carbonate, magnesium, within limestone, magnesium and calcium, right? So, you got to address the sulfur issue. Sulfur coming from where? It does come from volcanoes. If you wanted to say harvest it from a volcano, put it into a powder and then put it on your field, but naturally in your soil, where does it usually come from? Let's think about this. You go out into the forest and you go under a tree and there's a bunch of leaf litter. It's been rainy. You pull that leaf litter aside and you get a smell. It's a sulfuric smell. It smells a little bit like eggs because there hasn't been a lot of oxygen in there. Where does that sulfur smell come from? Well, obviously it's through decomposition, right? It comes from microorganisms. So if you have microorganism-rich soils, that you're actually going to probably hit your sulfur requirement if you're doing things like natural farming and lots of mulching and all that stuff. But most farmers don't do that, so they actually have to put sulfur in. Sulfur is an organic amendment. You can go to the store and buy it, and then you could use it as, it's a really, really good fungicide. It's that yellow powder. Now, where does that yellow powder come from? He just said it, from volcanoes. How do they get them out of the volcanoes? And where are those volcanoes? Slave labor, child labor. You've got to watch this as far as the sulfur goes, where you're getting your sulfur from. Get it from a reputable company if you're going to use this method. They literally use children, shove them into mines, and they mine out the stuff that kills them before they're 27 years old. Where does this happen? Chile, Peru. Okay, so you have to, in addition to understanding these materials, understand where your fertilizers come from. It's super important. You will never catch me using that stuff, even though I know it's probably the best fungicide that you can use organically. I look for other options, or I will chop my tree down before I use something that uses child slave labor, yeah? That's just me personally. You can do whatever the hell you want. But just know that unlike this, which comes from the beach, some crushed coral, it's dead coral anyway, it's not a big deal. We may be causing some erosion issues, but it's not as big a deal in my honest opinion as slave child labor. Okay, moving on. I don't want to preach too much. But let's look at the proportions that are typically needed for agriculture crops. If you're looking at the macronutrient requirement, obviously it's going to need a lot of nitrogen here, right? A lot of phosphorus. A whole lot of sulfur. Going from there, potassium, calcium, and then magnesium a little bit less. Everybody got that? Any questions on that?
Is sulfur and potassium usually the same?
What do you mean?
The grams?
Oh, depends on what you're growing. You're growing bananas. Huge potassium requirement. So it's probably going to look more similar if these are switched. But it's really dependent on what you're growing. But typically, you'll see that, I just want to show that at least on the nitrogen side, you got to understand that most of your additive is going to be nitrogen. Or most of the need is going to be the nitrogen need. Micronutrients. Let's go through these. We're going to look at the periodic table in a second. So if any of this is just becoming too much, just know that we're going to organize it in a second. But I need you to look at them independently to understand their functions, okay? Iron, typically found in high quantities in Hawaii, right? Lots of iron in volcanic soil. Fe, damn Latin. Iron. I don't even know how I would remember that. See, I learned it like forced through the periodic table, so it's like I wouldn't be able to do word. I don't know if I could do word association, but they don't always look like the abbreviation. Just understand that. Copper, Cu. Copper. Zinc, that's an easy one. Zn. Boron. These guys are gonna be metals, right? Mineral metals. Ow. Molybdenum. If you can't remember how to say it like I used to say it. Molybdenum. A woman named Molly from Canada, wearing a Canadian tuxedo. You know what a Canadian tuxedo is? All denim outfit. Man, they love to style that stuff out. So, molybdenum, molybdenum, MO. Manganese. That one's hard to say. When you're looking at the word, manganese. Sounds like mayonnaise. Chlorine. Like you put in your pool, right? Now, there's an MO, there's an MN, and there's an Mg. Look at them again. Magnesium, Mg, MO, molybdenum, manganese. They kind of sound or look like their words, okay? No surprises there, but just keep them straight. Where's your homework? Hey, look at number 2. Matt, why don't you read off number 2 for me?
In your own words, describe what the principle of limiting factors is.
Hey, we're going to talk about that right now. Pay attention. Principle of limiting factors is a really great concept that I think all sustainable farmers should understand, because you start to realize the importance of every action that you do. Now, imagine a barrel similar to this one here, right? Barrels have the planks of wood going up the side, all the way around, and then held together by a band, right? Well, let's imagine metaphorically that each one of these planks of wood is a different task or farm management resource, okay? Now, it could be the climate of your environment. It could be the amount of nitrogen that is in your soil. It could be your understanding of crop rotation, soil pH, sulfur. So each one has its own, metaphorically, its own plank, right? Now, you fill that barrel full of water or sand. Fill it up. A full barrel is a metaphor for a successful farm, okay? As the water leaks out of the barrel, it's a metaphor of things that are lacking, right? So here's the water or the sand. You got the planks of wood. We're all on the same page here, right? The band that holds it all together is farm management, resource management. The concept here that I'm trying to get across is you're only as good as your weakest link, all right? If I go along every day and I make sure that all of my minerals are at the right level, they're all at the recommended levels, and my plants are getting all the nutrition that they need based upon fertilizer recommendations. But I neglect to put lime in my soil and change the pH of my soil. And now my pH, because of all the nitrogen I put into the soil, is down to 3.5. No matter how much weed control I do, no matter how much operations I put in, if that pH isn't fixed, then that plank that represents that pH is way down here and the water's flowing out. Here's my metaphor, right? You're only as good as your weakest link. If you neglect any one of these things, or pretty much any task of your responsibility as a farmer, your crop will suffer. Here's my point. Nitrogen is just as important as calcium, just as important as sulfur, just as important as molybdenum, just as important as magnesium, just as important as watching your soil pH or making sure that there's disease control. Concept of limiting factors basically tells you you're only as good as your weakest link. The barrel can only be as full as that last plank is high. Did I make my point? This is a huge thing, because you could stand out on the field all day long working 12-hour days thinking you're going to be a successful farmer, but if you have root knot nematode and you haven't gone through the proper steps to ensure that you have that or don't have that, then everything that you do is for naught. It doesn't matter. You might as well go to the beach. I mean, it's just a waste of time. It's a waste of money. You can't neglect anything as a farmer. That's why 8 out of 10 farmers don't succeed past 10 years. Is because they focus on too few of these things, or they focus on a narrow set of functions or managerial duties. It's all encompassing. Got it? I don't want to bore you too much with that. You'll be able to answer number 2. No problem, right? Shouldn't need the video. All right. What is plant available forms of elements? Where am I going with this? Let me see. Ionic charge. Okay, you guys want to take a break real quick? Get some blood flowing. I'm going to do this a couple times. We're going to get into the periodic table.